Students from Waihi College are comparing the levels of carbon from soils managed under different conditions. It's part of coursework designed to raise their interest in agricultural science and farming, but the work is having far-reaching effects.
The objective was to get the students interested in agriculture, get them interested in science, and to make sure that we had a few of the potential engineers and lawyers switch from those topics into those that I think are more important to the future of this country. But it's gone way beyond that in the sense that it's given them a much greater appreciation of the issues revolved in global warming, the build-up of carbon dioxide in the atmosphere and how we might reduce that carbon dioxide.
Well, we used our core sampler to extract samples from the top, middle and lower parts of designated sites. These sites included dairy paddocks, maize fields and kiwifruit orchards, and we then placed the samples into labelled bags for identification.
Next we took 10 grams of the dehydrated soil and put it on a stainless steel plate and then burned it on the barbecue until zero weight loss occurred again.
This left us with only the silicon remains of the soil. All of the organic matter had been burnt off. We noted the weight loss, which determined the percentage of the carbon in the soil.
With the topsoil depths, we found that dairy and kiwifruit orchards were quite similar, with dairy having quite a bit of a higher topsoil depth. And we found that maize had the lowest topsoil depth out of them all.
And you don't want to be in this strip down here or that one over there. That's where the tractor wheels all go each time. That started about 6 years ago. We started doing research in the kiwifruit orchard here, and Zespri and on the cool stores, our pack house suppliers, jumped in on what we're doing instantly, and they've supported us with grants, but the most important thing they've supported us with is with their top personnel in the field. And so the students have really plugged into this science thing when they're dealing with a real scientist, as opposed to just me or one of the other teachers. It appears our work is some of the first in the country, but the fact that 14-year-old and 15-year-old students had access to the government to actually say, hey guys, we need to look at this again, we think you're wrong. Now what other government in this world would be so open and clear? I didn't think it was revolutionary until other people started to talk to me about it. But the results showed very clearly that kiwifruit and dairying were much of a muchness, but maize was of major difference. The thing that fascinated me is that it was the better soil that had the advantage of a deeper topsoil, but also higher percentage of organic matter. So there's a couple of theories there. One is that it gets to a stage where your topsoil is deep enough to filter out the nitrogen and the carbon. And the other theory is that once you've got a good group of organisms in the soil, with plenty of food, they actually expand exponentially. So from now on, you'd think that farmers should treat effluent as an investment, not a cost, because the change in the soil is, well, it's a win in every angle. Better filter, so it takes out nitrogen and nitrate, it locks up far more carbon, and you produce more meat and kiwifruit that goes out the gate. And that's got to be a fixed carbon, so you add it all together, and it would appear from what Dr. Brumby has found out, and with our work, that will turn the dairy industry and the kiwifruit industry into carbon credit sellers instead of having to buy carbon credits.
Much more milk solids, much more dry. This year's work that Clyde Smith and his colleagues are planning is very much a follow-up of what's being done now. We want to know how quickly do these changes in soil fertility occur? What are the factors that really do influence these changes? If we crop a soil, we know that we reduce the organic matter, but how quickly does that depletion carry on? Perhaps the biggest challenge, though, is to try to persuade our professional scientists that this really is a topic that deserves more attention than they've managed to be able to give it in the last few decades. The ability of the soil to absorb carbon dioxide in the form of carbon in the soil and remove carbon dioxide as a greenhouse gas from the atmosphere is very large.
This program was made with funding from New Zealand On Air.